We can move on to question number 2. Diethyl ether has the following structure. Which groups of protons are equivalent to each other? And then how many signals are expected in the HNMR spectrum? Okay, so first let's write down the structure of diethyl ether. You'll see that it's like symmetrical. And I can actually draw like a plane of symmetry right in the middle of the oxygen, just to help us visualize this molecule. Okay, so when we want to find out which groups of protons are equivalent to each other, we want to first look at the neighbors. And also the chemical environment of each photon. And what I mean by that, let's say we're looking at the protons in this first carbon. I'll label them A. If you look at the neighbors, it has a carbon with 2 other hydrogens. And you can say the same thing for these hydrogens over here. If you look at what it's attached to a carbon with 2 hydrogens. So let's look at the hydrogens beside it. This CH2, it has 2 neighbors. One of them is an oxygen, and one of them is a carbon that has 3 hydrogens. So we can say the same thing for this set of hydrogens right here. And you can see that the hydrogens in A and B are different from each other. So when we answer the question, which groups of protons are equivalent to each other, it's going to be A. Well, actually, I'll just follow the labeling that the question gives, just so that we're all on the same page. But I'll keep it the same colors. Okay, so if we look at which of them are equivalent, it's going to be A is equal to D, and also B is equal to C. So therefore it's option 3. Now let's look at the second part of the question. How many signals are expected in the HNMR spectrum? So we have 2 distinct sets of protons. Therefore, the number of signals will be 2. So it's going to be this kind of proton or this kind of proton. Okay, let's check out the answer from our junior tutor. A equals D and B equals C and 2. Note 2 signals, one is from CH2, the other one from CH3. So solution is correct. Okay.